I'm happy to be here today to make this presentation about something very close and dear to my heart, and that is looking for ways to improve the performance of safety instrumented systems. Within Saudi Aramco, we have a plan in place, an actual program to deploy technology where it's necessary and where we see a benefit. We don't pursue technology for the sake of technology's sake. We seek out where improvements are necessary and where we see clear opportunities for improvement. We try to leverage the cooperation of core suppliers, key suppliers in the industry. This can shorten the time between an idea for an improvement and seeing that new device installed within a plant. And we really strive to find ways where there's a win-win opportunity for people that if the supplier invests resources in the development of a product and also Aramco hosts the prototype testing and improvements of that both parties come out with something they can look to as a benefit. So these are sort of the key elements of our program, if you want to call it our strategy, to pursue improvements in our safety instrumented systems. Now, you've heard a lot about safety system design in the last 10 years. Quantitative risk assessment, safety integrity level assignment, probability of failure on demand calculations. All this work really focuses in on the design side of the safety instrumented system coin, if you will. What we're trying to do with our work at Saudi Aramco is to look at the other side of that coin. We're also very on board and we're very proactive about understanding how to design safety systems based on risk. But we also want to look at what happens to these safety systems after they're installed in the plant. We're trying to look for ways to improve their performance over the entire safety life cycle. So how can we improve, make life simpler for the operators and the maintenance technicians that have to work on these systems? And we've heard some of those comments over this time in this forum about making technology easy to use. That's music to my ears because that's exactly what we're looking for as users of technology. We want to make this technology work for us and improve the way our systems perform. We're looking for ways to make safety systems respond to safety demands. That's number one. But only when it's a safety demand. We want to improve this potential idea through introducing these new communications techniques. And of course, we're looking for ways to detect faults at the field level within critical safety devices, notify us that these things are happening, and communicate with other systems so that we can record and track when these diagnostics occur. This whole objective is really boiled into this paragraph or this sentence here, that what we're really trying to do is use the potential of new technology to improve the overall safety system performance. And what I want to do now is go through a couple examples to show you how we've done that. These are easier things to say than to do. But I have a couple examples that'll help demonstrate how we've been successful in making this happen. And they also demonstrate the long-term relationships that are required to do it. The first one is a system that we put together with Cameron Flow Control. This dates back to the mid-90s. And where we started was with hydraulic shutdown systems. Now, anybody with experience within oil and gas and wellhead control and shutdown understands what I'm talking about with hydraulic shutdown systems. There's no databases involved, there's no remote communications. Many of the well sites don't even have power. So we're starting with something that is 1960s technology. And what we did is we had operating systems that we demonstrated through design that were safe, meeting all the safety requirements for redundancy, fault tolerance, and all the rest of the design side. But where we found problems were with living with these systems long term. Hydraulic systems are difficult to maintain. and our proponents in the field were asking us to do something to help them. Find ways to improve these systems, remove some of the operator intervention, take the human out of the functional testing where possible, improve the performance of the systems. So where we were starting was with a hydraulic-based, proven, conventional system. And what we ended up with was, back to the work we did with Cameron, we developed a spring-to-close electric actuator that was necessary to bring this technology forward. We had safety logic solvers. We had voted transmitters. What we didn't have was an electric fail-safe actuator that was suited for the wellhead application. So to fill that gap, we partnered with Cameron. We developed actuators. We put them on wellheads. We failed them. We redesigned them. And eventually we came out with a commercial product that we can now deploy to improve the way the systems perform, the way we test them, to provide automatic sequencing of the testing, and to even introduce ways to make it much simpler for the operator to even verify tight shutoff of the critical valves in the system. Just an example of something we started to work on in the mid-90s that we're still deploying today. And of course, there's a next step, but that's for future. Another example is in the introduction was mentioned Smart ZV. Well, what Smart ZV was a collaborative effort, a cooperation between Saudi Aramco, Metso, and Emerson. Companies working together with a need to improve safety, the performance of emergency isolation valves, which are the key element within safety systems. What we wanted to do in this case was to take experience and benefits that were demonstrated in the control system world and roll those into the safety system world. Leverage the know-how to improve the performance of our critical safety systems. Here's where we started. Emergency isolation valve in a pipeline, continuous process. These valves are not control valves. What they're in this process for is to stop the flow. If there's a fire in a downstream plant, if there's a rupture of a flow line or a trunk line, these valves close to mitigate the loss or to prevent releases. So they have to function. They have a very critical function. They need to operate when we need them to, but we don't want them to operate without our demand, okay? Very serious consequences of that as well. Where we started was 1970s technology, operated fine, it was doing the job, but it was very limited in capability, complex to work on, and relative high cost. Perfect candidate to introduce some technology. So here came Smart ZV, and Smart ZV really, we went together with Metso, we went together with Emerson and said, okay, let's take what you've learned about these digital valve controllers and control systems on control valves and apply this knowledge with some changes. It took complete new product rollout, but to control our emergency isolation valves, to give us online and offline testing capability, improve the diagnostics that we're able to do and thereby the performance of the system. And the real win-win was lower the cost. We get a better system with much improved performance and capabilities with a lower cost. And then we didn't stop there. This Smart ZV was introduced in the early 90s, and till a year or so ago, it's pretty much rolled out conventional technology at this point. And what we did then is join the Foundation Field Bus for Safety Instrumented Team effort. Along with several other end users, Saudi Aramco participated since 2003 in a collaborative effort with other end users, with suppliers, with technologists, safety experts, getting together to talk about how a Foundation Field Bus protocol for safety should function, how it should be used. And we met together and worked on this over the years so that we could see the deployment of this next technology to take this Smart ZV even further. And I'm happy to say that we've got a system ready to deploy in the field now. It'll be a small-scale system thanks to the close cooperation with Invensys and the resources that Invensys has put behind it. We'll have a system installed at our Juema gas plant later this year, where we will be the first installation of foundation field bus in an operating facility. This will give us a chance to take it for a test drive, see what we like about it, see what we don't like about it, and move it forward with our suppliers to the next level of commercialization. So these are two examples that show what we're doing at Saudi Aramco with moving forward with the capabilities of our safety systems, and they serve as an example, but they really all are part of what this development process would look like. If you could create a model to say, describe how this all works. And again, it starts with identifying a need. So you're out there with existing safety systems doing their job, but if you could do something different, if it was possible to do something that you can't do now, how would you do it? What need could you meet? What gap could you fill? Exploring the alternatives. Is there something available on the marketplace externally? Is there some capability internally that could be developed? This is sort of the exploration stage. If it turns out to be something new and unique and novel to you or to Saudi Aramco, pursue the intellectual properties for it. Go through that gyration to ensure that that part of the equation is covered. Then develop prototypes and move into field evaluation. Now, this field evaluation is another area where the end user, the owner-operator, as it was called earlier today, we get involved to host these evaluations to see how these systems really perform in the intended application. We move from a field evaluation of a device or two or three to a limited deployment. This is real important because we want to see how scalable the solution is. A solution may work great on a few devices, but if it's going to be eventually deployed company-wide, we have to verify that all the issues involved with scaling it up for greater deployment are taken care of. So we go to a limited project deployment. And we go back through this little side path there to update the design. It'd be nice if you just circled right through the process, but often there's issues that arise during this evaluation period, and it requires updates to the design before we move to standards updates. And these, by these standards, I'm talking about Saudi Aramco engineering and design standards and our specifications that we give to our contractors when we have a large project. So at this stage, we're saying that this technology is ready to deploy. We've done work with our suppliers, we've prototyped, we've done some field evaluation, limited scale testing and deployment, and now we're ready to call this an accepted design practice for the company that is now out there on the table as an option that any of our contractors or design teams could use on a future project. This is no longer considered new technology at this point. And then, of course, it's a continuous cycle. We're always looking back, receiving comments from project teams and proponents about the performance of systems and saying again, okay, we've improved, we've done some incremental improvement, but what's the next step? What's the new technology that's ready to be deployed? So that's our development process. And so in a nutshell, just to summarize now, we at Saudi Aramco are very serious about safety, and we have an active technology program in many areas, but one of those areas is safety instrumented systems. And the key elements of that is that we pursue technologies where there's a business need. We introduce new solutions to existing problems. It isn't something that it was a lightning bolt. These are problems we face every day in the operating facilities. And we seek out ways to improve this situation. And we look to collaborate with key suppliers to find a win-win for both parties. Now that was my presentation. I'm short and sweet, But if there's any questions, I got a little time. I'd be happy to take some questions. Larry, is that okay? Okay. All right. All right. Thank you.